In this video, I'm going to explain you how to find the dimension of the four subspaces. So let's just recap quickly what are the four subspaces. The first is the column subspace. The second is the null space. The third is the row space dimension. And the fourth is the left null space. So let's see step by step how we can find the dimensions of these spaces. So we are given a matrix B in the form of its LU decomposition. So this is the matrix L and this is the matrix U. So let's see how we can first calculate the column subspace dimension. So if I want to calculate the column subspace dimension, we look at the matrix U which is given to us and we find the number of pivots. So you can see that the first pivot here is this is the number, and then you have zeros, and then this is the first non-zero, and then you have 0. So these two are going to give us the number of pivots. Therefore the dimension of C of B is nothing but 2. Now after finding the dimension, if I want to find the basis for C of B, then all you have to do is take the pivot columns of L. So we know that this is a pivot, this is a pivot. So now you go back to L and then you just pick off these columns which belong to pivot number 1 and pivot number 2. Therefore the basis for C of B will be in the form of a set. So since this is pivot number 1, the corresponding column here is 1, 2, minus 1. And then since this is pivot number 2, the corresponding column here is 0, 1, 0. So this we write in the form of a set. That will give us the basis for C of B. Now next, if I want to calculate the dimension for the null space of the matrix B, then that is nothing but the number of columns minus the number of pivots. Very simple. So the number of columns that we have is 3 and the number of pivots which we've calculated in point number 1 is 2. Therefore 3 minus 2 will give us 1. Now to find this 1 vector, 1 is the value, 1 vector in n of B. So now you look at U, which is this particular matrix. In the third row with all zeros, plug in 1. Second row will just give us minus 1 and third row will give us minus 3 by 5. To understand this much better, you can see that row number 3 in U has all zeros. Therefore this will become the free variable x3 equal to x3. Therefore I am saying that you plug in 1. In the second row, if you see, this will give us x2 plus plus 1. Therefore this will become minus 1. And then you will have here 5x1 equal to 3. Therefore x1 will become minus 3 by 5. Therefore the vector in the null space after back solving will give us minus 3 by 5 from the first row, minus 1 from the second row, and 1 from the third row, because third row has all zeros. Therefore I'm going to have x3 equal to x3. So this will give us the vector in the null space of the matrix B. Now if I want to find the row space dimension, then that is nothing but the dimension C of B transpose. So we have already found C of B in the first point. All you have to do is first transpose it and then you find the dimension of that column. So this is nothing but the number of pivots, as I have explained you in the notes, that this is nothing but the number of pivots. That means that the dimension of C of BT, row space dimension, is same as the dimension of C of B. So dimension of C of B is nothing but 2. Therefore this is going to be the same. Now I want to find the basis for the row space. So you use the 2 pivot rows. Earlier here we had used the pivot columns. Since this is a transpose, now we use the pivot rows, and once you use the pivot rows, this just becomes 503, which is written in a transpose form, and then you use 011, which is written in a transpose form. So that is the difference between point number 1, dimension of CB, and a row space dimension of CB transpose. Now lastly, if I want to find the dimension of NB transpose, left null space, then this is nothing but the number of rows minus number of pivots. So 3 minus 2 is going to give me 1. Now how to find the left null space? If I want to find the left null space, the process is you invert L and make B equal to LU. Here we have B equal to L into U. May look like L inverse B equal to U. That means now we'll invert L. So once I invert L, let's say L goes here mathematically, L inverse into B equal to U. So this equation which we are given initially, B equal to L into U, to find the left null space we must make it look as L inverse B equal to U. So now for that, this is what the equation we have written, L inverse B equal to U. So we first find L inverse. So inverse, there are many methods to find the inverses, and we take L and find its inverse. So this turns out to be the inverse. L inverse into B equal to U, which is already given to us. Now we choose the third row as it corresponds to the third row in U, right? So we choose the third row here and it corresponds to the third row in U, full of zeros. Therefore, a basis for n of bt is nothing but, since this is 0, you just correspond it to this particular row, right? So the basis is nothing but, since it will be transpose, you write it in the form of set which is transposed, therefore you write 1 0 1, right? So I'll repeat again, to find one of the basis for, or the vectors in left null space, you first invert L and write it as L inverse into B, which is equal to U. So we have found the inverse for L. There's B equal to U, and once you do that, you can see that this third row corresponds to all zeros. Therefore you pick off this particular row, which is 1 0 1. Because it corresponds to all zeros, it's not going to change, and therefore you write 1 0 1 as a transpose, because we are finding B transpose. So that will give you the basis for n of bt. So now this was the method which was used to find the 4 subspaces if the matrix is given in the form of LU decomposition. Now I'm going to explain you here a faster and easier method to find the 4 subspaces, right? So let's say we have been given a matrix A which is 1 3 2 2 6 4 0 1 1 and 0 0 1. So the first thing that we need to do is to convert this into a row reduced echelon form. That means complete ones and zeros and upper triangular matrix. So keep reducing this matrix till you get the matrix in this particular form, right? So in this particular matrix, now we can see that C1 and C2, column C1 and column C2 are the pivot columns, as they have 1 and everything below that is 0, right? So first we calculate C of A, which is the column space of A. So vector in A corresponding to pivot columns. So you can see here that this is the first pivot, right? This is the first pivot here, 1. So I take the column corresponding to this pivot, which is 1 2 0 0. So that becomes the first vector in C of A. The second pivot is this, therefore I take the column corresponding to this in the original vector. So you'll have 3 6 1 0 as the second vector for C of A. So very simple, right? Second, I need to find R of A. So transpose row vectors from the row reduced echelon form and write as column vectors. So I'm going to take the row vectors and just transpose them, the row vectors from RREF, and just transpose them and write as column vectors. So you have this pivot here 1 0 minus 1. So I'm just going to transpose and write it as 1 0 minus 1. And then you have this particular row here 0 1 1, which consists of the second pivot. So I just write it after transposing it. So you have 0 1 1. That will give us the row space of matrix A. So very simple, right? Next we need to find the null space. So I've already written the answer to null space as 1 minus 1 0 0. Now this can be obtained by 2 methods. The first method is the method of solving AX bar equal to 0 bar, whose solution will give us the null space. So all you have to do is take A, which is take the row reduced echelon form of matrix A, which is this, write it here, then write your x1 x2 x3 because you have AX bar equal to 0. Solve this and its solution will just correspond to this matrix which I have written. So this is the traditional way of finding the null space, which we have seen earlier. There's an easier way of doing it. The other thing that we can do is, in the pivot columns, change the sign of the elements. In the pivot columns, change the sign of the elements and replace 0 in the main diagonal by 1. So all I'm going to take is in the non-pivot column, right? This is the non-pivot column. So this is the non-pivot column here, right? These two are pivots, 1 and 0 and 1 and 0. So these two are pivots, we'll leave them. In the non-pivot column, that is this particular third column, change the sign of the elements. So this is -1, I'm just going to make it +1. This is +1, I'm going to make it -1. 0, 0 does not change. If one of these elements falls in the main diagonal, just change it by 1. So when I do that, I'll have +1, I'll have -1. Since this 0 comes in the main diagonal, this becomes 1 and this remains as 0. So it just turns out to be 1, -1, 1, 0, which is same as that particular answer, right? So this answer is supposed to be 1 here, right? So you have two methods by which we can get n of a. One is the traditional method of solving ax bar equal to 0 bar, and then you get this answer here. Or you just take the non-pivot column from the row reduced echelon form, change the sign of the elements which already exist, and if any of the element falls under the main diagonal, just replace it by 1, you'll get your answer. So this is a faster way of doing that, right? And lastly, if I want to find the left null space, again I have written the answer already. So there are two methods again. Solve A transpose x is equal to 0. So A is given to us, find its transpose, multiply it by x. This should actually be x vector and 0 vector. Once you solve them, you'll get x1, x2, x3, x4 in this equation, and then you can pick off these elements. So this will correspond to -2, 1, 0, 0, which is this vector, 0, 0, 0, 1, which is this particular vector. So you can do it the traditional way, right? Or there's an easier way. So you find A transpose. There are many methods of finding A transpose. So the answer to A transpose is this. For this A transpose, find the row reduced echelon form, which is this. Now look at the non-pivot columns. So in this row reduced echelon form, you have this as the non-pivot column, you have this as the non-pivot column. Change the sign of the elements and replace 0 in the main diagonal by 1. So I'll take this non-pivot column, I'll change the sign of the elements, so this becomes -2, this is 0, 0, but this 0 falls in the main diagonal, so I'll change it by 1. So I'll get -2, 1, 0, 0, and that is the first answer here, right? Then I'll take the other non-pivot column. You have 0, 0, 0, and then there's a 0 here. Since that falls in the main diagonal, I'm just going to change it by 1, so you get 0, 0, 0, 1, right? So you have two methods of finding n of a and n of a transpose. Either of them are good enough, but there's also a shorter way to find the null space or the left null space.